Hi again. Well, I cut off that last video there because I ended up making a mistake in the variation within part and I didn't want to be confusing. So we're going to do that. I'm going to do that part in this video. I did catch it, but it took me a little while, so I don't want to confuse anyone. So here, now we're going to do the variation within groups, and that's called the MSE, or mean square error. But again, if that feels like too much right now, don't worry about that. Just worry about the process, and then we'll come back to that a little bit. Okay, so now for the variation within, we want to get a sense of the average spread of the groups. Okay, so this is the baseline, or the denominator of the whole F ratio. Okay, and N, capital N, is the total sample size. Okay, so just like we use capital X bar for the overall mean, in a lot of cases the case doesn't matter, but since in this case we have groups and an overall, it matters. So capital N is the total sample size, and the degrees of freedom for the K, we have K groups, the degrees of freedom add up to N minus K, okay, or the total degrees of freedom, N minus K. So let me show you this formula here. Again, it looks worse than it is. So we have a summation, which means we're going to add. We have the degrees of freedom per group times the S squared, or the standard deviation for the group squared, okay, over the total degrees of freedom N minus K. Okay, so let's go ahead and do this. So we have 25 minus 1 is our first degrees of freedom, or I could have just written 24. And now we're going to use our S's, right? So we're using our N's for degrees of freedom. We're using our S values here. Okay, so then my first group is 1074.023 squared. So we can't add standard deviations, but we can add variances for independent variables. So that's why we're squaring the standard deviation to get the variance. Okay, so let me make a note about that. We can add variances for independent variables. And we ran into this too with two means and two proportions. We use that also in those standard error formulas. But that's why we're squaring these, because we can add variances. We're still weighting it by the size of each group roughly, but that's why we're squaring. And so I bet you can imagine there's going to be some kind of independence condition, because we need independence in order for this formula to be valid. Okay, plus the second group, 25 minus 1, again, these are all the same size, so it just happens to be kind of nice. 779.7391 squared. I'm being very careful because I made a mistake last time. It's easy to do, so that's why once we do this once, we're going to use technology once we understand the process. Okay, 25 minus 1 again, times our third S is 593.3976 squared. Okay, great, and that is all over capital N, which we have 75 data values, minus K, which is 3 groups. Okay, that's going to be 72. You might also notice that that's the same as 24 plus 24 plus 24. That's our total degrees of freedom. Okay. Okay, let me go over to the calculator on Desmos. So I'm going to do an open parenthesis because I know I'm going to have to close it at the end to divide. And I'm just going to do the 24 to make it easier. So 24 times parentheses 1074.023 parentheses squared plus 24 parentheses 779 7391 close square plus 24 parenthesis 593.3976 square. Okay. And so now I get the top value. So I'm going to write that down, okay, and then I'll show you. 507 273 40.33. Also, they're not always this large. It just happened to be because these microliters? Microliters are so small, there's a big, really big number, and then it kind of gets larger and larger. Okay, so that is the number that I got, and we're going to be dividing by 72. That's a 75 minus 1 for each group. So let me go ahead and do that. Okay, good. Desmos knew what I wanted and closed that parenthesis there, so now I can do 72. And I'm getting 704,546.39. Okay, I feel like every time I do this I get a slightly different number, so I'm sure you can relate to that frustration of every time I do it I get a different number. Okay, so I wrote this down. So my overall variation within, this is for the denominator of our F ratio, is 704,546.39. So let me show you how we can double check. We talked about the patterns in this output table. So these numbers are right here. So let me go back to the top. This 44, 34, 8606, that's our sum of squares, and we divide by the degrees of freedom, which is 2, and then we get the next number over, which is 22174303. Okay, pretty cool, huh? So that's why I'm doing this, to show you how it works, and then maybe do it by hand once or twice, but then once you feel like you have made sense of it, then you can use technology. And then the error is the variation within, and that's going to be our mean square error. So we have 507, 273, this one's 36, and this is 40.33, so they're close. I think it has something to do with how the S's are rounded, what place they're rounded to. And then we divide by 72, which adds up to n minus 1 in total for the degrees of freedom. And then we get 704,546.33 versus 39. So very close there. Okay, great. So let's just make a note of what this is. So this one was the sum of squares of the error. Okay, and we divide that by the degrees of freedom, just like we did up here. We had the sum of squares for the groups, and now we have the sum of squares for the errors, and then that gets us the MSE, or mean square error. Okay. Okay, one last thing. I want to go back and actually write down that F ratio. Okay, so the F, got just enough room at the bottom here. F ratio, I'm going to write it again from the top, is the variation between over the variation within. Okay, so I'm going to write my two answers and divide them. So for the MSG, or the numerator number, we got 22174303. For the denominator, we got 704 546.39. And it looks like I got 0.33 in the last time I did it, so the next video might be slightly off. But when we divide the two, we get 31.4732. 4732. Okay, and I think I repeat this part in the next video because I forgot to do that in my original one. So I'll see you in the next video where we continue on and see what we do with this F ratio. Okay, see you over there.